This is going to be another lo-fi brainstorming session here. Since the last time I did a couple of these, I've had some time to think about a few other ideas that I didn't talk about into the mic and start implementing them. So I'm going to get you caught up real quick on the biggest idea. So I was listening back to the first two sessions, thinking about what I was saying there, and I think what stuck out to me the most as the most important thing to look into next is that in the game jam for the 7-day roguelike challenge, I organized the game into sort of a spatial structure. At the highest level, you are exploring the dungeon, and it is organized in a data structure that represents the levels of the dungeon and how they connect to each other, the topology between the dungeon levels. And I kind of have a gut feeling that that is a wrong idea. That if I structure the game around the physical space at the highest level, that it won't feel like a story, because stories, like I was sort of alluding to in, I think, either the first, one of the previous two brainstorming sessions, stories involve editing. Like if you were reading a good book, they wouldn't explain to you all of the minutia of how someone navigated through space if it was not relevant to the narrative. Similarly, with like a movie, they edit out the portions of traveling and covering space and maneuvering through space that don't add anything, right, to the narrative. And I kind of feel like a story game is always going to feel better and more like it's about a story and less like it's a crappy interface to a adventure game if the top level structure is a story shaped thing instead of a space shaped thing. So I wanted to take another crack at this whole thing with an idea of how do I organize, instead of having levels of a dungeon and a pointer to which level I'm currently in as the sort of most high level structure directing gameplay, what if gameplay was directed through a conventional story graph, right? That's the only structure I could think of that was still simple and concrete enough that I could actually write one down and yet had story shape as the story graph. And as I explored the idea, I became more and more convinced that this would feel good. I've sort of sketched out a story graph for the next iteration of the prototype that I'd like to make. And the idea is now that as you progress through the story graph, early points feel very fixed and locked in like a story graph, but it starts to open up more and more and blend with systematic gameplay elements deeper and different levels of and different nodes of the graph. So each node in the top level graph represents a state you can get into in the story, but then rather than simply presenting the player with the decision of which path to take next, they interact with some gameplay, and the gameplay determines which path comes up next, and then that directs the story graph further. So that's the model I wanted to play with, and now the levels of the game are, instead of being contained inside of these spatial nodes, in a sense, they're contained inside of these narrative nodes. But besides that, the rest could remain relatively similar. Like you go into a node and then random encounters occur, but instead of those random encounters being relevant to what space you're in, those random encounters are relevant to what state of the story you're in. Okay, so to get that idea up and running, I decided I would introduce an idea into the code base called a director. So I started by being able to model these story graphs in code. Let me show you a snippet of that. It's a pretty nasty like macro macro format that I'm using. And it pretty clearly points to the need to use a visual directed graph editor for this kind of data construction. But before I go and build one of those or figure out how to stitch one together out of existing software, I wanted to see if the data structure itself was useful for other purposes. Like I wanted to see if this idea was the right direction. I don't want to go and get good at editing story graphs if editing story graphs doesn't get me where I want to go. So I use this to prototype out the first act story graph that I have in mind. And then I started attaching things to the nodes. And the very basic thing to attach to each node is just a story fragment. So if you'll recall in the jam, I constantly had a current fragment pointer that I was using to render out to the user what the next piece of the story, And I've eliminated that, and instead I have this node pointer that points to one of the nodes in the graph. And there's some subtleties in how I've decided to structure this that I have not fully tested out and that I haven't explained to you yet. But that's part of what I'm going to try to figure out now is as I explain them, if I can make sense of them to you, then it will help me to implement it more cleanly. But I'm not quite there yet. There's another issue that I'm running into. So I was attaching these story fragments to each node in the graph at first, and I knew that I was going to need a thing called a director to replace that, because if all I can do is attach a story node at each, or a story fragment at each node, then I have just a classic interactive fiction engine where you build the story graph, and at each node of the story graph, you specify what you tell the player on that state and what choices they can make to move to other states from there. That's just classic interactive fiction. And I want to sometimes be able to do that. Like I want to be able to put you in a dialogue tree where your options are just a fixed set of things from a list and they flow into other things in the graph of the story tree thing, right? So that's not a bad thing to be able to do, but I don't want that to be the only structure available to me. I want something that can, when I enter, like when I do a part of the story that's like, you are now exploring the dungeon, I should be able to keep a single node that represents that state of the story, but replace the sort of fixed one-time interaction with a single screen with an entire exploration of the dungeon. And in addition to that, I started running into the idea that I might even want to keep this and just put another story graph inside of a node as its director, right? So if a director can be any arbitrary thing, it can be a simple story fragment, it can be a whole separate game that you play to determine an outcome. It could also be another story graph. And while that might sound like silly and redundant, it's kind of a useful organizing mechanism. So on my top level structure, I kind of have an outline of the first act of my story game, and I want to add a lot of detail about how you navigate your arrival in town. There's choices I might want you to make, like, do you initially go and get a spot at the inn, or do you go and mingle at the tavern first? And that might be a small, there might be a small shift in which things, it's like a small detail of the sort of start of the game rather than a big detail, but it could be relevant. And then you have a day of preparation where you can pick a few options out of a larger list of options to do to prepare. So shopping or going to a black market, researching by going to like a library or something like that, or by talking to the locals. Maybe hiring someone who can help you, or looking for the instructions on how to get there by yourself, which at the top level of the graph, the whole big split is when you're in town, you either end up deciding to go with a guide that's going to show you the way to the dungeon and take you through the dungeon, or to go by yourself. So at the top level, when I outlined my story, I'd already decided that was the split I wanted to be the primary thing you had to decide in town. But I don't want to just splat that in front of the player as a single screen. I kind of want to build it out, let there be a couple of decisions they make that start to influence the systematic pieces of the game a little more. So preparation style, what information you might have gathered, what relationships you might have started to build. And along the way, you ultimately have to either decide if you're going with a party that you hire, like these sort of guides, or if you're going to go and search for it by yourself and sort of, go into the wilderness on your own style. And so that decision is represented directly in the larger graph, and then I want to build a smaller, not a smaller graph, I want to build another graph that represents the entire node of what you can do when you're in town. So in town isn't just a single screen, it's now its own web of things you can do. And I like organizing it this way because it kind of gives me options for how to split the graph up into smaller graphs. which makes it easier to draw them. It also follows the principle of like function calls pretty nicely. So instead of having one giant data structure that represents the entire concept, I have a high level graph that represents the highest level of the structure of things. And then that calls down into more detailed pieces where necessary, right? So I started implementing this, and what I want to do now is just switch to a video feed, look at some of the code with you. I think I've already made some mistakes on the first pass of the implementation, and so my main goal here is to talk through what I was trying to implement, why it has problems, what those problems are, and what changes I want to make and the justifications I have, finally, for why I think those changes will get me closer to the properties I was actually looking for. Okay, so let's start from here. I am looking at the macros that define the top-level story graph, and I'm just going to point out a couple of the structures here, and then we'll go a little deeper. So the state macro declares a new state in the graph. States meaning the vertexes of the graph, the vertices of the graph. Path being the directed edges of the graph, right? These are the paths between states. So here I declare a state, and you can see the macros actually declares a new local variable with the given name. It also puts a development, like a label on that, so it saves that string. This is just to help me when I'm making like, when I'm walking through these and I haven't, and I need to inspect what thing I'm looking at from like through the runtime, right? So these are development/debug labels essentially, and they're just taking the same name as the variable to make it automated. Then I have these paths. They have a source and destination, which are two of the states, so like intro, in town 1, 2 states, a path between them. And then this part here is a code. I actually have them defined. Let's pop open this. So I have a list of these game moves, and this is specific to this game, but the construction of the graph does not depend on the enum directly. It's just expecting a U32 code here. And so, for any given game, these can be different, and the story graph concept remains the same. It's just a unique integer ID for this particular action. Some paths you'll see have the same ID there, but they always are on different sources. So if I'm on the Woods 2 state, I can only use success once for Woods 2, but I can reuse success here for Dungeon Alone 1 and for Woods 1 and so on, right? As long as I don't put any two paths having the same code into the same source state, then there will be no confusion about which path to take when the player makes a move. And you'll see a little bit more how the code works and why it needs to work that way in a little bit. So that's cool. And then in addition to the states and the paths, each of these is considered a node of their own, their own kind. So all nodes are the same node structure, but states and paths are the two different kinds of node structures that I have. So they're both using the story node struct. Let's see this guy, right? But some of their features are shared, and some of them are unique to states, and some of them are unique to paths. So, hold on, there we go. So the next thing there, the 0, that's all these zeros you see mean that there's no content attached at those locations. But here and here, there's content attached. So one way I can make a director is to just provide a story procedure. So I have this, story fragment idea. That's still the same as it was before. There's been a little bit of refactoring, but mostly it's the same. And, I can specify out the strings and the styling I want on those strings, like fonts and sizes and colors, and attach the interactable alives there. The payloads now are the way I planned on doing them. So a payload has, there's just one kind of payload, and it's a call, but I can also prep that call with parameters. Now, this move choose character function is special, and this might still be the sign of a problem, But let's take a look at it and discuss it a little bit. So the move choose character, and this is a smaller issue, not relevant to the main thing I want to talk about, I don't think. The main thing happening here is we are loading up a parameter that tells us what kind of character the player wants to be. So thief, beast slayer, archaeologist gets loaded up into the parameters, right? And then this reads off that parameter, saves what player type we're going to have, and also does a graph move. And the graph move, you can see it says story graph move, that goes into the root graph, like the main graph at the top of the story structure, or the top, like inside the game state, right? So inside the game state, we have a story and a story pointer, and it tells it to figure out the next node and select that node. So the state update is a thing which figures out which node we want to point to next, given this move integer. So for instance, if it's the choose character, right, move, well, we saw that earlier. Choose character is what happened right here. It tells the intro state to move through this path to the in-town state. Now, the interesting bit that I'm skipping that I'm now going to go back and cover is that you can also land on a path instead of on a state. So this setup here would take us from intro state to the in-town state and would not land on the path. But that's because when we do this graph move, it goes, right, here's graph move. When we do this graph move, it takes in the move and returns the next node that we should select. This determines what next node to select. And when we look at how it works, it's taking the path code, it's scanning through all the paths that are associated with the current pointer. So the current pointer has to be a state kind. It can't be a path. If we're already on a path, then graph state update doesn't make sense. If we are on a state, then we take in a move, a path code, right? We check to see if any of the paths attached to the current state, putter, right? That's the state we're starting from. We're looking for what's the new state we should be at if we started here and we use this path code. So it selects one, and then it goes, okay, determine what story node should be next. So default, it just stays on the current one. So if the path code is just garbage and doesn't match any of the possible paths, nothing will happen. But if we found a match path, that match path itself becomes the next state. So this is saying the next state is equal to the path node, not the state node. But if the path node doesn't have any content attached, which it can check by seeing if the director pointer is null, then it skips the path and goes straight into the destination node. Now, that's all fine. It's just a little bit maybe extra detail than what you expect, but the idea is I might want to, in the process of going along a path, say like, okay, this story state and this story state both represent an idea I had, but I realize I also really should include some writing because there's a couple different ways to enter that destination state. So I need to include a little bit of writing sometimes that transitions us from one state to the other. And I could do that by inserting another node in between them and only ever putting writing on the nodes or on the states. Or I could put a state in, if I have a state A and a state B, and there are a couple different ways into state B, but on the path from state A to state B, I want to have some flavor text that describes the transition. I could do that without attaching stuff to the paths if I just insert another state in between, but sometimes it's just nice to have a sort of a few options to like gracefully transform a structure over time. Right? So it's not, building this isn't just about finding the most logical, pure, perfect structure that simply and cleanly defines a story graph or a story engine. It's about building a data structure that you can work with over time. So you can sketch out an idea, you can iterate on that idea on day 2 and make a little progress. You can iterate on the results of day 2 to make more progress on day 3 and so on, right? So the data structure has to have some room to grow gradually in small increments. And I think attaching content to a path as a shorthand for, hey, there's only one way to proceed through a path. You can't go into a path and then exit out something other than the destination, but there might still be a good reason to display some extra flavor text there, or to even have an entire director that like plays a little mini game that's guaranteed to end in the same spot, but might still either add something to the experience or even modify the game state that lives outside of the graph. Okay, so when I do graph state update, I could land on a path, but in the case we were looking at, that doesn't happen. We land right on the next node or the next state, right? So that's what you need to know there. But let's go back to now the choose character, right? So this is the payload function that gets referenced in the intro. And so in the intro, it's saying, hey, when the player clicks on this text, you're going to do this move, and that's going to have this parameter, right? Or this move and this parameter or whatever. Those come in here, and then they update the graph as the final thing they do. So they do some work on the state, it modifies the state, and it updates the graph. The current node pointer moves along the story graph that exists in the game state. Now, when it gets to the in town part, we have a different kind of director, right? So this is where I started writing what I thought would be a more interesting type of director. And so it's not just a wrapper around a single piece of text to display like it is in this case, right? Here we're just showing one fragment, and that constitutes the entire of the intro state experience. But the in-town 1 experience is controlled by this QUD, standing for the, QU being the quest namespace, and D being a suffix for the directors. So just like I have story fragments that are QUS, now I have directors that are QUD. So if we look at the arrive in town director, we can start to see a little bit more about what these do. So they can be invoked in a few different ways. When you enter into a node with a director attached, I want to give the node a chance to initialize its state. I need to be able to ask the director, how do you render out the fancy string? I need to be able to ask it, how do you process a payload? And I'll show you why that needs to be done. I also have a cleanup option that isn't needed for this particular director, but you could imagine wanting to, for instance, clean up some memory that you had set aside for this particular system of interactions, right? Now, there's this thing which builds a new story graph. So this is essentially, and this comes with a header. So this is the header for the arrive in town director. And this is the state that is being controlled here. So we have another story graph and another story node pointer. This is for the sub graph that controls walking around and doing stuff in town, or rather not walking around, I shouldn't say, but controls the flow of story upon your arrival in town up till the first time you leave to continue your adventure towards the dungeons, right? So that's what this director's job is to do, is to provide that story graph. And so I implement the story graph right here. It's not complete yet, but it's like I started sketching it out. And I run into something kind of annoying. So I get to the point where I have a story fragment for arriving in town, and I've got all the writing for it and stuff. And then you have some decisions to make about, are you going to go and look for lodging right away, or are you going to go visit a tavern? It's the first thing you do in town. And so I have game moves for each of those, and that's already starting to get a little annoying. It's not the worst thing ever. I could do something other than having a separate integer code, but throwing these all into an enum isn't really causing me any problems yet. That's not the part I'm worried about. But you can see the move I make now is called move director handle. And when the director handle move gets called, we have to go back to the main structure. So director handle, what is this? This is the function which looks at the current node in the game state's story graph, looks at its director, and passes the parameters for the payload onto that director to be handled. And then that gets passed through to this case of the switch, which processes payloads. It's taking the parameters to do so. And then finally we can see like, oh, so this director, this is saying, oh, process this by having the director handle it. And then it's reading off what moves to do and running the story graph state update on the story pointer that lives inside of this state. So that works just fine for now. But what happens when I have another layer here, right? So I have my top level layer, which is the story graph that represents, the major game state. It contains the top level flow of the story. Underneath that, I now have this arrive in town story graph that I'm going through its narrative. So it's sort of like I'm reading chapter 1 now, and chapter 1 is what happens in town, and that is itself its own story graph. Okay, so that's good, but what happens if in the middle of going to town, you go to a shop and there's a director I end up writing that's a shopping director that controls the shop in town, and it's meant to be reusable so that lots of the commonalities between interactions with the shopkeeper and the options for what to buy all interact through the same code paths throughout the game, right? Because there might become a point where I start wanting to dip into the systematic parts here. And yes, so far the only thing I've done is taken a story graph and said, let's do story graphs inside of story graphs, which ultimately could just be equivalent to a much larger story graph. What I haven't done yet, and there is one exception to that now, because if I kept going, you could also imagine recursion in your story graphs. But that doesn't add anything particularly interesting to the experience, except the ability to get like arbitrarily deep into the weeds about some cyclical behavior in the graph, right? Besides recursion, the story graphs inside of story graphs are just ways of breaking up large story graphs into smaller story graphs and like composing those story graphs together at higher levels with other story graphs, right? So that's not really new. That's still just plain old-fashioned interactive fiction structuring. It's not until I start going to a director that isn't a story graph that this would get interesting. And once I start doing that, I can imagine very easily that I want my directors to be more reusable, because like I was where I was starting with all this, I want something like the shop to have certain properties that are sort of gameplay systematic properties that will remain the same at every step of the story. And of course, I might also want there to be some unique stuff in the trappings around that, depending on the story, the moment in the story that you're interacting with. But for instance, if the shop is going to keep track of its wares and you've bought certain things, those should still be missing when you return to the shop later in the story. So some of it should not be, some of the state should not be just in the graph. And some of the flow through that graph, like the process of purchasing something, doesn't need to be implemented twice, hopefully. Okay, so with that idea in there, that means that most likely, even here in chapter 1, where I'm in the arrive in town graph, I'm going to end up wanting another layer of graph inside my nodes as soon as I start to do something a little bit interesting again, right? So if I want to send the player to the shop, I need to be able to push another director. And now the problem is, if I have a story fragment, that uses the move director handle payload processor, this becomes ambiguous, right? So at the root level, there's a graph and a story node pointer, right? If we look at the quest.h game state, we have a story and a story pointer. And what happens every frame is we use the story pointer to determine what to render. And then if the user clicks on something, they just directly tell us what top level function to call. And that function call then references into game state, makes some changes, updates the graph state, updates the pointer into the graph nodes, and the system keeps chugging along. The problem is, okay, once I'm one layer in, how do I code this payload? right? Because I want to kind of be saying like, this is actually not move director handle. Like that feels wrong because now I'm saying that I know how this fragment is being used. It's being used as the content of a director that is contained within the root level rather than a part of the root level, if that makes sense. It's sort of a sub, it's one of the directors inside of one of the nodes in the root graph rather than being content that is directly rendered out of the root graph. And so I can no longer use the move story path or move story graph and move story path continue. These helpers, which I wrote as payloads that I thought would sort of control moving through the story graphs, can only control moving through the top, the highest level story graph. And then I have to have the director implement similar things for the subgraphs. And that's doesn't feel very good. And what's worse is once I have another layer of depth here, if I have the assumption that the only time, so when you're in the arrived into town state of story, the only kind of move that the director can handle, the only kind of payload the director can handle is the one it puts here. So the person writing the fragment can't say like, oh, this option is sort of like QU move the XYZ move of the game, and this one over here is like the ABC move of the game. No, anything that is gonna have to go down a level to the subgraph is just going to have to go to the director handle, and now everything's on these parameters instead of the function I call being able to do something there. So I think that the big problem here is I thought what I would do is, and this is a common mistake, this is why I don't like, abstracting too soon, but it's very easy, and this is what I've done is I've abstracted too soon. I thought, okay, I have a story graph. I will attach a director to each node in the graph. So the nodes, again, being states and paths, I'll attach to each of those a director or a null pointer just as a default. Will always be safe too, but if you put that in there, it'll skip over it if it's a path, and it's basically an incomplete game. You can leave it null, and then the game will just render out some dev stuff instead of playing a game for you. But point is, if you attach these directors, they can be anything, right? So this is where you note it. When you hear that thought process, the director can be anything. You should think, okay, so it's an abstraction layer. Behind that statement, what we are really saying is we have something like a virtual table. We have a function in this case with a couple of different commands it can process and some state that is unique to it, right? This is like object-oriented style abstraction. And it's a mistake. It's a mistake because the feature I really need here needs to be folded back in all the way to the core structure. If I decide that I'm going to make these directors that can be anything, and then some of them want to be contain their own story graph and walk through their own story graph, I'm going to end up having to re-implement things like the story graph state and the story graph processing and the story graph displaying. All of this is basically equivalent to the main loop, right? I can go and just find, right here we have, here's how we display a fancy string at the root level. What's the difference? Basically nothing, except that this node came from the game state and this node came from the arrive in town state, right? And so when we are in town, this points at the in town state. It goes to here, sees, oh, there's a director. So let's render out using the director. And then this goes and says, oh, well, this director has a story graph. So let's grab the story node off of, so what this director wants to do is grab the story node off of its state and run that logic again. And so what this suggests to me is I abstracted too soon, because if I have an abstraction layer that can do anything, and one of the common things I want to do is to reconstruct all the behavior of the root level, then I have a problem because it shouldn't be necessary, right? This should have already implemented everything. This code should have been good enough to handle this somehow. And so I had to duplicate it because I have this barrier where I can do anything, but the thing I want to do turns out to be the same thing that would have happened up here. And then what's worse is now I have to somehow pass through the fragment system the knowledge that the way we process this payload is buried inside of the abstraction, right? This is how we process the payload. It's not a global function because we wanted it to be something that could rely on that state that is sort of bundled in with the rest of this. So I thought, hey, process it in here, but it's just wrong. What I need to do instead is I need to use the same solution that is used for making function calls work. So I was saying before that these story graphs inside of story graphs are very similar in the way that they are useful to the way function calls being called from inside of, or functions being called inside of other functions is useful. It's sort of like at the highest level, we have a description of what this thing is doing. And then along the way, some of the statements of what this thing is doing are actually expanded into an entire other block of statements when you like go in and see what they actually are. So, I mean, we're looking at code here. I can just point at this. Here we have a function. And in order for it to render, it's going to call the fancy font and fancy color functions and the fancy story node dev functions. From the perspective of this function, it's described in terms of 3 statements, but each of these functions are then described in terms of multiple statements. So we have this reuse of the concept of a function within itself. Not necessarily recursive. It's not that the function depends on its own self, but that the concept of any kind of function is a thing which can contain within it reliance on other functions or on itself, right? The concept of a function includes statements, and statements includes the ability to call functions. I think we need the same, and the way you end up implementing that so that it works well and in non-surprising ways is with a call stack. And I think I need the same thing here. I need to fold in to my core idea before I introduce any abstraction. I need to be folding into the core idea, the idea that that I won't just be having one layer of graph state here, right? I need at the root level of the game state there to be an understanding that we actually have a stack of states and a stack of story graphs. And at any given time, we are not just in one state, but we are in a sort of hierarchy of states where the current most active state is sort of the same thing as like being inside of a function that is currently running, and the things that are lower down in the stack, the things that were pushed earlier on, are sort of suspended, but they contain within them, as a part of their processing, as a part of their logic, as a part of their entire runtime, however way you want to think about it, they contain within all of the stuff that they achieve the stuff that the subgraphs achieve, right? So then what I need is a stack here, and I need to just think about like what kind of operations would I put on a stack. I would need like a push operation to say, okay, from here what we want to do is push a new graph onto the stack, and it'll start walking through that graph at the root level. And I need the ability to pop. And we also want to think about like what would it mean to pop and push. And in this context, it means that say I arrive at a node, right? So say I'm looking at let's go back to the description of, so say I'm looking at this graph here. I start at intro. Intro just says, oh, the way you process me is to display me. You show this fragment, and that fragment has some alives in it. Whenever they get clicked, you process those to figure out what to do next. And those fragments use the structure of the graph to specify how to change the graph state directly, right? So if you click on something in the first intro fragment, they are all wired up to say, oh, when you click on me, my effect is to take you is to choose your character. All three of them choose your character. They have different parameters, but they all choose your character. You then arrive in the in-town node. And then what happens is that node must immediately say, oh, I do not have content on me. Rather, I have an instruction to push another graph. And that graph needs to get pushed, and then you actually need to process the initial node of that graph, right? So the difference between what I've written here and that is, one, there's a core notion of a stack here inside the game state, so that instead of walking a single story graph, we are walking story graphs that are stored in a stack, and we are always walking on the top of the stack. And I need to make a different change, which is that when I arrive at a node in this graph, whether it be a state node or a path node, I need to think a little bit more carefully. So path nodes already have the idea that sometimes you don't stay on them when you select them. You actually select them only to discover that what you need to do is move on right away, right? So it's like the logic of the fragment for QUS intro told you to select this path, and so you selected it, and this path said, nope, when you select me, you actually go straight into in-town. I don't have any content to show you along the way, so you just skip me and go right to this state. What I need to be able to do is to specify here the idea that when you select this state, what you do is you go, nope, I don't actually have any instructions about how to display things or about how to handle events within the context of my interactions. All I have is an instruction that says when you try to enter this state, what you've really done is you've expanded an entire graph. And the way we expand an entire graph that is within this node is we push it onto the stack. So this should now have the ability to do one of several things. When I select the node, I move on to another node in the same graph, or I push a graph. And I might also want the ability to say I pop a graph. So let's go back and talk about how that would work. When I look at this, so this would be an oversimplification, but let's say that all we're doing in town is we get some intro and we either decide to go to the inn or to the tavern. If we go to the inn, we wake up well rested, and we can begin trying to find our way to the dungeon. But we've missed the opportunity to socialize in the evening before, so we didn't meet anybody yet, and we end up having to go, look for the dungeon alone in the woods. This isn't the story that I actually plan on constructing for the game, but it's just a good example. So this would then give if you choose to go to the inn right away, then it's the same as saying, okay, you get the benefit of being more well rested, you get a cheaper price for your lodging, but then you don't meet someone who's going to be able to guide you to the dungeon, so you have to go alone. And if you go to the tavern, you're going to spend a little bit more cash because you're going to spend some at the tavern, and you're going to have a slightly higher price at the inn. But you're also going to meet a group of guides who are willing to show you the way to the dungeon and take you into the dungeon. And so depending on which of these you choose, you get one of those results, right? So if that's the way I wanted it to be, I might say, like, oh, well, when you select one of these paths, I will have some stuff I want to display here and here. And then once I've displayed that, like to tell you what has happened as a result of your choice, I want to have a button that you click that then takes you back out to the other graph, right? So that would look like, I'm going to type some new code in now. Go to woods, right? So we have a state that's like go to woods, and we have a state that's like go with guides. Now, I could add paths that take us from the in arrive state to the go to woods state, and the tavern arrive state to the go with guides state. And these can just be like our continue action. So they're nothing in special. It's just like the game, it's a turn page. There's no choice. There's no affirming or anything. It's just you continue to the next page after you read what's in this state. So you can imagine I attach some state or some story here, I attach some story here, and then I want a button that says continue that is built into those fragments. So this has the story fragment here tells you what happens and gives you the continue button. This story fragment tells you what happens and gives you the continue button. And the continue buttons then take you here and here. And then when you arrive at these states, what should happen is it should immediately go, oh, I don't have more story for you. I have an instruction that says to pop the graph stack and to apply a particular graph move to the graph below me, right? So when I pop the graph stack, what I'm saying is, hey, if the graph stack got pushed in the first place, it got pushed because of an instruction at the layer below, right? The graph below us must have issued an instruction to do the push. So now that we're popping, I want to send some information back. This is just like a return from a function call, right? So if someone calls this function here, they are expecting that not only does this function take over computation for a little while, but when this is done with its computation, it does send something back to the caller that lets the caller benefit from the progress that was made, right? Understand what decisions got made and stuff like that. Same thing here. Some decision got made inside this subgraph that needs to now get exported to the containing graph. And so we need the ability to pop and apply a graph move in one instruction, right? So that would be kind of like a return, I think, right? These would have the instructions to pop and do the, let's see, what do we got? We've got a search state and a higher state, or search move and a higher move. So this would be something like graph pop and apply the move search. And this would be like graph pop and apply the move higher. And either way, we're applying that move to the previous graph, right? And so that's an instruction that should make sense. That's almost everything that I want to go over here. There's just one other issue. So all of that is cool and sounds good. But again, remember, a part of the plan here is to not always be in a story graph. So while I want the stack of story graphs to be folded into the core structure rather than having a stack of abstractions, because that makes it much harder to reason about how a piece of code communicates its it's not that it's harder to reason out. It makes it much more laborious to specify the operation, since each implementation of the abstraction will be specifying a separate copy of the story state stuff and the communications of pushing and popping. And it's pushing and popping that is completely hidden from the game's core structure because it's all hidden inside of these abstractions. So each abstraction sort of has the concept that it knows that there might be a next thing after it within the chain of abstractions, but there's no explicit stack. I'm saying move all that out to an explicit stack, make the operations explicit, and we can still use an abstraction, but those abstractions will communicate with each other through this sort of like this graph stack interface, right? This graph stack interface will give us the way to carry information back and forth between levels of the stack in the same way that like function calls carry information back and forth through passing parameters in and returning data out. There's only one issue, which is that say I'm a director that's more interesting than this one, right? So I started writing a director that just turned out to reveal to me that I don't want to start with directors when my first goal is actually to have graphs within graphs. I want to implement graphs within graphs with a simple graph stack. But eventually I will have a director that's something like the gameplay loop for exploring the woods looking for the dungeon, right? And when you're in that state, that director might still want to call out to graphs, but it's not itself a story graph. That might be something like a random encounter system. It might try to balance like, okay, we'll give a certain amount of fight encounters and a certain amount of rewards or like cool finds. There might be choices to search more slowly, to spend time to get more, or to go more quickly. There might be opportunities along the way to say, you know what, I'm getting off the woods. I'm going to go and look for help in town and try again tomorrow or something, right? There might be different choices along the way that vary from being very story relevant to being just sort of RPG standard stuff. But somewhere along the way, that director is going to want to push a story graph again. So while it's making a decision about what to do next that does not go through a simple story graph, it then might want to push a story graph, and I'm not quite sure how that part would look. Especially not the pushing part, because I think that part would be relatively easy. So let me give you an example of how I think this could look. Imagine, right, we're talking about going into the woods here. Imagine there's a director here, and that director, when you first enter it, is going to give you an intro fragment that's just like describes the woods to you a little bit and asks you if you want to move quickly or if you want to move quietly through the woods. And here's your two choices. And then, depending on what choice you make, it tweaks the parameters of how it generates encounters. So some of the how it generates encounters is randomized, but there are parameters to it that are determined by your choice, such as like how much time is spent before you get to the destination, how many rolls are there for encounters along the way, maybe some other things, right? And once it's rolled to see what kind of encounter you hit, it might roll a combat encounter, it might roll some kind of cool discovery that you found in the woods. It might roll that you've gotten to the end of the woods, right? There's a couple different things it might come up with. Once it's chosen one of those from your decision, it then uses that to decide what to show next. And that could very well be something that I want to implement as another story graph. So I might want to say, oh, you're encountering a combat encounter. There's actually going to be a story graph that runs combat encounters now, and it won't be purely a story graph, right? There's a story graph that's, again, systematic within itself in certain ways, but it might be a thing where I want to say like, oh, actually a part of how the combat system is modeled is through a story graph, so that the story of a combat encounter can include connections with other parts of story game stuff and isn't entirely isolated out from story game stuff. And so I might be pushing on this combat encounter story graph, and it might take over for a little while, show it, like deciding what to display. And that doesn't mean that it's going to forget that you're in the woods, because there could still be some global state about like what kind of location data to use when describing location stuff. It's not going to forget like what stats you had or what things you've had. All the global state still carries into the combat encounter, so the combat encounter can describe things in ways that are thematically correct for the narrative. But what happens when the combat encounter ends is the interesting part. When it ends, it needs to pop back to the Woods 1 director, which is not a story graph. So what is it really popping back to? Well, it's popping back to the root graph, because the root graph is not, we never actually left the root graph, right? When we enter the woods, it initializes this director, it then shows one story fragment, and when the player continues, that modifies some state so it knows, okay, we've shown them the intro to the woods, and they've made a choice about how to explore, and then it decided what to show next. That decision about what to show me next pushes a graph on, and when it pops back to me. But it does not necessarily pop back to me with an instruction about how to move through this graph now, right? When it pops back to me now, it's returning something to the director that is we're still at the bottom of the graph. At the bottom of the graph stack, we're still sitting on this state the whole time. And when it pops back to me, it's returning something, but that something tells it how to evolve the director's state in a systematic way, right? The director sort of made a function call by pushing something onto the graph stack. And when the graph stack, when that thing pops, it's popping back and giving the results back to the director, but the director isn't saying, oh, I'm just canceled as soon as this thing pops. I actually continue on afterwards. So that way you can have something like, okay, you beat the encounter, then that means when you popped, it goes back to the director that contained the combat encounter, and the director says, okay, the player hasn't gone, this was our first encounter of the woods. We haven't been here long enough to advance to the next state. So woods 1 can advance through success, retreat, the player can die, right? So we haven't gotten far enough and we haven't done enough encounters to count this as success yet. We need a little bit more. And so I'm going to have to present another decision to the user or to the player to keep this segment going, right? I'm not done. Or you might come back out of the combat encounter with the player choosing to retreat. And then you might want to say, oh, well, if the player is retreating from the combat encounter, then I want to export that to the whole graph handler, right? So retreating from a combat encounter becomes becomes an evolution of the state when you're in Woods 1, but success from the combat encounter does not necessarily become success in Woods 1. So this is where I do want the abstraction stuff, because I do want to be able to say, hey, the director here has the right to decide how to handle the value that was returned to it from the graph that it pushed onto the stack. So basically, to summarize the whole system I'm thinking of, imagine we have, some cases will just be a single solitary piece of story fragment with some choices that link directly to next options. That's something I want sometimes, very flat. Classic interactive fiction structure. Sometimes I'm going to want graphs within graphs. So instead of having a director here, I might want to say, hey, this is a point where you push a graph onto the stack. I'm not telling you what director to use. I'm actually not equipped with a director, but I am equipped with the instruction that when you try to select me, what you actually do is you push something new onto the graph and select its initial story state. And then when that subgraph pops, it pops to this state again and sees, oh, this state doesn't have a director. Therefore, instead of asking the director what to do with the pop, there's a default behavior, which is we take the pop and we use it to evolve the story graph, because that's what we would want it to be when there was no director. And then to put a director in there is to say, hey, there's some systematic thing that's not a story graph. There's some gameplay code that is structured in a way that might involve random number generation. It might involve stuff that's a lot more computational stat block stuff. Maybe it's a simulation. Maybe you're making a game that isn't even an RPG, but it's got a lot of story elements, in between platforming levels or something. So in those parts where it's no longer just a story graph, a director shows up there, and the director gets to decide what to do with popped data, like data that got popped to it, right? So returned to it from other graphs. It also gets to decide to push things onto the graph whenever it wants, right? So that's the new structure I want to try to build. Hopefully that makes sense. Talking it out has certainly clarified for me what all the pieces are and why I want them in certain ways. But that's what I need to adjust to next. Thanks for hanging out and checking this out if you did, and see you guys around.